enables the production of only quality products by automatically eliminating the production of defective products at an early stage. The key to Jidoka is that machines are made to adjust to workers, rather than forcing workers to keep pace with the machine. To implement Jidoka on the line, we have incorporated intelligent automation in our production equipment and refined work procedures for our teams to build quality into products at each point and prevent defective items from going on to the next process. One such idea is the pairing of our rope switch and andon, an electric signboard on every section of the line which provides a visual control tool. With andon, every team member has responsibility to the extent of stopping the line if they see something that isn't standard. The ultimate objective is to help prevent problems from happening, reducing line stop time and increasing process stability. If team members judge there to be any abnormality, they can use a rope switch and andon to indicate a problem has been detected. Here, a team member finds a problem and pulls the rope switch above the production line. A chime sounds, and number 26 on the andon lights up in yellow to inform the team leader that there is a problem at number 26 workstation. The team leader moves immediately to the workstation to investigate the situation and provide assistance. If the problem is solved in the prescribed section of the line, the team leader pulls the rope again. This turns the yellow andon light off, letting all production workers know that the line has returned to normal. If the abnormality cannot be corrected in the prescribed section of the line, it automatically stops. The andon light then changes to red. In this way, the color of the andon light lets everyone know the status of the production line at a glance.
La demanda alisada del cliente toma la forma de tarjetas Kanban situadas en un tablero secuenciador. El secuenciador representa el programa que define el orden en el que serán retiradas las diferentes referencias a lo largo de la jornada. Para administrar los envíos, el carretillero saca del tablero secuenciador las tarjetas Kanban correspondientes a sus órdenes de pedidos. A intervalos regulares de unos 15 minutos, extrae una o varias cajas de productos acabados del stock situado a pie de línea de producción. Recupera el Kanban de fabricación y lo devuelve a la línea mediante un lanzador.
La ligne de la planche de bord reçoit par le biais des séquenceurs la demande exacte du client. Après, donc, la ligne de la planche de bord en fait répercute par des lots de production sur les lignes annexes son besoin en approvisionnement. Et ces mêmes lignes annexes répercutent également sur notre service injection en fait leurs besoins également en approvisionnement.
El aprovisionamiento de la línea tablero de instrumentos se efectúa mediante el pequeño tren. En cada recorrido, el conductor del pequeño tren recupera las Kanban de los productos retirados y las coloca en la caja de construcción de lotes. Esto permite preparar los pedidos en las líneas de ensamblaje precedentes, como por ejemplo la línea de guanteras. A lo largo de su recorrido, el conductor del pequeño tren transmite de línea en línea la demanda del cliente. Cuando se constituye un lote, este será colocado en la cola de espera al pie del último puesto de trabajo de la línea de producción. Es importante estandarizar el circuito del pequeño tren. Como en el caso de los circuitos Kanban precedentes, el tamaño de los lotes también es fijo. En esta prensa, un lote equivale a 4 horas de producción. La puesta en marcha de un sistema de retiradas frecuentes y regulares permite a la línea de producción trabajar continuamente al takt time. La idea del takt time consiste en producir exactamente al ritmo del consumo del cliente. Si un cliente consume 3 piezas cada 30 segundos, habrá que producir entonces 3 piezas cada 30 segundos. Si la demanda del cliente varía, habrá que adaptar el ritmo de la línea de producción al nuevo takt time, y ello sin pérdida de productividad.
Alors quand le takt time du client évolue, le système de prélèvement évolue de la même manière. Ce takt time se répercute sur la ligne de fabrication qui le suit au plus près et par boucles successives Kanban, toute l'usine tend vers une fabrication à ce même takt time.
Un repère rouge mis en place sur le lanceur nous avertit qu'on doit augmenter notre capacité à produire. Donc là, on va mettre en place rapidement en fait une deuxième personne, chose que l'on peut faire grâce à une proximité des postes de travail.
Esta flexibilidad depende de la facilidad con la que un operario puede pasar de un puesto a otro para compartir el trabajo, lo cual implica que los puestos de trabajo han de estar próximos y no ha de haber obstáculos que dificulten el tránsito.
Continuous flow production is one of the most important types of industrial manufacturing concepts. It supports the efficiency of work systems through orientating the production according to the customer tact. The to-be-produced product serves as the foundation for the design of a continuous flow production, in this case, a multi-piece pneumatic cylinder. The individual components are mechanically manufactured and thereafter assembled to the final product. In the assembly system shown, several inefficiencies are obvious. The assembly of the product in batches generates unnecessary stock between the assembly stations. The distribution of the working stations creates inefficient transportation distances. Furthermore, the working stations are unevenly utilized, which leads to unproductive waiting times due to missing material. These types of waste can be optimized through a continuous flow production. First, the individual tasks in the assembly are documented. From this, the assembly plan is generated. Subsequently, the necessary process time for each individual task of the assembly is determined. This can be determined either using an analytical method, such as real-time measurement, or in cases of a new system planning, synthetic methods such as MTM. In addition to value-adding assembly tasks, there are also secondary processing times for handling, checking, and packaging to be considered. The generation of these assembly times serves as the foundation for balancing workloads in the flow production. The determined process time results can be visualized in an operator balance chart. For each of the 5 workers, the steps carried out and their respective task durations are compared. The total sum of all assembly tasks leads to a process duration of 265 seconds. Currently, it is clear to see that the workload is inadequately distributed between the operators until now. Therefore, the customer takt of 60 seconds is not achieved. A large part of the assembly time is composed of non-value-adding activities, such as searching for parts, unpacking, and especially transportation of material between the single workstations. These unproductive activities can be in a large part eliminated through an optimized continuous flow production. The remaining assembly time of 110 seconds per piece divided by the customer takt of 60 seconds generates the required demand of 1.83 workers. Rounded up, 2 operators are needed in this case. The required workload can then be distributed equally between the 2 operators without the customer takt being exceeded. Thereby, the chronological priority relationships between single elements need to be taken into consideration. For example, the packaging of the product can only be carried out after the assembly is completed. Through the use of digital tools in the Learning Factory, the result of balancing the assembly line can be validated directly in a virtual layout design before the optimized assembly system is physically implemented. With the assistance of assembly simulation, many significant improvements can be visualized, such as the achievement of an even material flow, the avoidance of stock, and the reduction of transportation distances between the working stations. If the simulated assembly layout and the intended takting have proven to be suitable, they are realized physically in the Learning Factory. Workstations are consolidated in an assembly line. Necessary tools and fixtures are installed. The U-shaped line is particularly favorable as it allows the only 2 workers operate the entire assembly system without having to bridge large distances between the individual workstations. Should the assembly line's capacity to be increased, additional operators can be deployed into the system at any time. If the newly designed work system is now started up, effects of the changes are immediately and clearly evident. The material is staged ready for use and as close as possible to the place of consumption, what effectively helps to reduce non-productive times within the assembly process, for example, for searching and unpacking parts. The reduction of the batch size to just 1 piece, combined with an even balancing of the working steps, induces that components are further processed directly and no intermediate stocks are piling up between the individual stations. Necessary tools are ideally positioned directly at the operation point. Using roller conveyors, input components can be provided to the assembly line and final products can be channeled out efficiently. In particular, however, optimal capacity utilization of the workforce is approached through the synchronization of work steps, while the material flow is taking place rectified.
Hey Megan, what are you doing?
I'm putting together the new 2P10 solo kit.
Yeah, I know, that old bag. This is the old way we were doing it. It's terrible. So this is going to look a lot nicer. We have the sleeve.
Yeah, the sleeve helps everything stay contained so it's not rolling around in the bag. And
That looks good. Have we got a time on this yet? We figured it out?
no, we haven't.
We're figuring 25 cents a minute for us to do it. So anything under 3 minutes, we're in good shape. So let's see what kind of time we're getting on this one to do it.
Right, and that took even longer than before because I accidentally hit the cool button on there.
Oh, okay.
Because I'm having to hold it. And
Andre, can you get me a timer? Okay, Megan, let's go ahead and do it.
All right.
Let's go ahead and time this, and let's see if we can get this down a lot faster.
Okay, let's
go
do
ahead.
Right.
Okay, done. What kind of time?
45 seconds.
Okay,
Okay.
so let's look at this right now. I'm looking at this, and I'm not sure that I like this.
Right.
I mean, certainly, hey, this looks a lot better, right?
yeah, for sure.
For sure. But this doesn't look clean here. So let's try to fix this and get this maybe in a little different way. Let's try to do that, Megan. Let's see if we can get that
Okay.
maybe straight up and down or something.
All right,
don't you
let's
think?
switch our inserts.
Okay,
let's move our
switch the
inserts.
inserts.
Okay.
So one thing I could think we could do right now is just, you're reaching down here for everything. Why don't we put everything up on the table and see what happens?
Alrighty, let's put it
do
up and make it
Let's do it.
standard.
Okay, so here we go. So we've got our glue here, we've got our cans here, and we've got that there. So now you're not going to go down below.
Awesome.
Okay.
Except for the gun. All I need to grab is my heat gun,
Okay, so let's go ahead and try that
which
now.
is good. All right.
Let's do one real quick.
Okay, ready?
Yep.
Here we go.
What's our time now?
35 seconds.
10 seconds. Not bad.
We cut 10 off.
And you know what that was all about? Movement. So the
Okay.
distance it took you to travel from here to here as opposed from here to here, this is much better. You
Oh,
guys-
a lot less.
Yeah.
And
that's
another
pretty
thing
cool.
is she's going from reaching down up here and then putting the sleeve up. What if we put the sleeves
Let's
up
do it.
higher?
Let's
do
change
it.
it right now. That's a good one, and let's retime it. Andre, excellent point. I really like the way you came up with that. All right, so we just put a box on there, make it
And
really
what if
simple.
we made the gun stationary too?
Yeah, we'll do that. So why don't you pretend to
hold
hold
it
the
right
gun,
now.
okay?
Pretend to hold it.
Yeah, he's going to hold the gun, so you don't even have to mess with the gun. And
Awesome.
then what if we put a foot pedal where you press on the gun with a foot pedal to make
That
it turn
sounds
on?
like an awesome
so now
idea.
both
I've got
your
a foot
hands
pedal.
are free. Okay, got a foot pedal?
I've got a
okay.
foot pedal.
Foot pedal's in. We're going to put a foot pedal on there.
Awesome.
This is cool. Andre's going to be our little guy to hold it.
And I
Not
brought
such
my
a little
2P10.
guy.
I brought my 2P10 inserts down because
Okay.
they come right near the
Right.
activator, and I'll
Excellent.
try putting them on before I put.
Awesome. Let's do it.
Cover
Let's
on.
see what happens.
Okay, let's do it.
The only thing that matters here is the clock. If the clock tells the truth, whether or not the system worked. So we went from 45 to 35.
Right.
We're trying to beat 3 minutes, which we've already
Right.
obliterated that.
So we're already saving money.
Tons.
Tons of
okay?
money.
But now we want to make it so easy. When you walk over here, you say, oh, this is a piece of cake, instead of, I got to fumble with those stupid things. That's what we want to get away
Exactly. Exactly.
from. Okay, Andre, are you ready? You messing around over there? Okay, no messing around, buddy.
Ready to go.
This is serious.
Go. Okay, so first. Down.
Okay, that's good. What's the time?
30 seconds. Saved another 5 seconds.
Another 5
Just by
seconds.
moving things around. Okay, what's
what if
next?
we put a cone over it so you wouldn't
She's not
fumble with
fumbling
the
what's going over the
sleeve?
top. Okay, let's get a cone. Let's try it.
Get a cone.
Do we have a cone?
That one.
Here,
right
you got a cone there? Okay, let's try this. All right,
Awesome.
let's do it again.
Okay, so I'll
Let's
put the
move
cone
gun
on
over to this
first.
side.
You want to go to that side? So I'll switch places.
It's a great
Andre,
idea.
You go over there.
It's a great
Now
idea.
this is incredible how we're just taking this thing down to nothing so
is
quickly.
awesome.
The foot pedal right there.
You got the foot pedal?
Good?
Okay,
All
everything's
right.
good.
I think we're
All right,
good.
let's rock and roll. Let's
Okay.
see what happens.
Go.
Right, leave it
And
a-
it's 10.
Here,
It
okay.
rocks.
Then
And it's front, then it's
Ah,
done.
that was, you
it
know,
pulls it tighter,
That's cool. So right in the front, not
right
even
in the
putting
front.
the heat there.
The heat does not even
Killer.
touch the activator.
Okay, what was our time?
27 seconds.
3 seconds.
3.
Okay, let's
What
look at
if
this.
we took these sleeves and flipped them around so that way when she grabs them, she could just
Unbelievable. You
flick
guys
it
are
with her
thinking, this is
thumb and put it right on.
awesome.
You are awesome.
That is it. Let's
Okay,
try that
let's
now.
try it.
God, this is amazing,
Alrighty.
you guys.
Here we go. Awesome.
Maybe-
Long.
Cool.
Take the-
Comment here, you guys. Whenever you're doing a process, what's our time first?
23 seconds.
We're getting it.
What?
23
That fast?
seconds.
That was quick. That's good.
Let's do it again.
Okay, here's the point. Every time you do something, this job is broke up into different elements. Grabbing this, getting the can, getting the glue, heating it. Those are all different components. What we want to do is get this down to maybe around 20 seconds. That's our goal.
All right.
But the way we do that is we just take 1 second off of every process. Rather than try to get one thing all the time out of one, if we just make 1 second out of every step, we can get the time we need. Does that make sense?
Yes.
So think about it that way. Think about a process as a bunch of little processes, and we work on every one of them. Okay?
All right.
Let's go ahead and do it again. So what are we doing different this time? I think you were going to work on this, right?
I think I was going to put the insert and hold the insert first.
Okay.
That way
Let's try it.
The insert's in and
Let's
out.
see what
Slip
happens.
it
Grab
and
the
just
bottle with the insert at the same time.
yeah, bottle insert then cone.
Good.
Since
So
this is only
they're
one-handed
they're
as
two
well.
the same motions rather than do one motion then another, so that's more time.
Okay,
Good
we ready,
point.
Andre?
You are on this,
Okay.
man.
Hey, sir, go on.
Find a place to put the cone. What's our time?
19 seconds.
Look at that.
Rocking. 23, 19. So we started at 45, then
Down to 19.
we went to 30, then we went to 27, then we went to 19, 23, 19. Okay. This is pretty awesome.
This is awesome.
And 3 minutes. We do anything under 3 minutes, we're saving money.
This turntable is still, it moves now. And
And
now
we
since
really
we
don't need it to move anymore,
we need
right?
something that doesn't
So what's
move.
the next step?
We need a solid station
Okay.
to build these.
So let's go ahead and build a solid station and come back to this right now, okay?
All right, let's do it.
Great, let's go.
We made a hole right there to hold the gun, so I don't have to hold it anymore.
This is cool. So it's just down and dirty, just
Regular
OSB,
plywood, scrap wood,
right? Our shelving, our racking system, so everything's just down and dirty,
our speed
easy.
braces,
Good.
shelf for inventory.
And we got it the height that Megan wanted it,
That's
right? Okay.
Another thing we did is instead of restocking everything into POPs, like
Okay.
big, we made places for original boxes that we just cut open and they're right there, ready to
Wow,
go.
I like this, Andre, because now you can actually see the levels in here. So very simple. We even canned it back, and we even used our own glue to can it back. Again.
We put a PVC pipe around the heat gun because when I was reaching for the glue to add it into the
Wow.
kit, I was afraid of being burnt. But
Good
now
idea.
it doesn't matter how many times I brush up against this, and no matter how hot it is, I won't get burnt.
Oh.
We also made our cone stand since
All
our cone
right.
was flailing everywhere.
Good.
We glued it to the table so it wouldn't flail everywhere along with the cone.
And so it's not going to get lost. Somebody else comes up here that you got to train. They're going to know where
Right.
the cone goes. Everything's pretty clear. But I might note, we put this down here, and if it's in the wrong spot, is that a big deal, Megan?
Nope, take your tri-blade. It's just cardboard 2x10, cut it
Right.
off, and even if you ruin the cardboard, doesn't matter. Get another piece, slap
Remake
it on.
and away you go. So
It's
we
cheap,
don't
it's
care.
easy.
Just get it in place. Let's try it. Let's time it because the clock tells the story.
All right.
Okay, let's
Let's
do
do
it. Let's
it.
see what happens.
Okay, we ready?
Okay, here we go.
Here we go.
Cone goes on, sleeve goes in. So still a little fumble there, but much better.
Yeah.
Definitely much better. And of course, yours is getting warmed up here with the new station.
Just getting
that
better.
goes in there. That's good. And
Move
then we
it
got our
over.
foot pedal down below. Doing that. Both hands are free. That's a really nice feature. Okay, we're done. What's our time?
19 seconds.
Not bad. So we're about where we were. Let's see if we can improve it. So what can we do here? Megan, do one more. Let's take a look. Oh, you know what? Here's an important note. We put magnets in here because we noticed that Megan was kind of fumbling around. So we actually put our magnets in here, and now the can stays in place so that when she's actually going here, she's not fumbling with that. Is that working for you?
Something that I have noticed is after I have everything onto my can of activator and it needs to come over here to be heated up,
Right.
it slips. It catches on
Catches
those
on it.
magnets.
So the magnets work, but they don't work. They actually
work,
create
but
a
they
problem.
don't work.
So
So
let's cover those up. Let's take them out real quick. And the important point here is you try something, and if it doesn't work, it's no big deal. We just take it out, readjust, and keep going until the clock tells the truth.
And if
okay.
you notice, we also did the same thing with the magnets. We made them so they could come out just as easily as they went
You
in.
got it. Okay, now what we did here is we got some PVC material with our adhesive on the back. Of course, we make this stuff, so it's easy for us to do this particular thing. And we're going to make a nice, clean runway for Megan to work on so everything's totally smooth. Okay, Megan, we're back in business. Let's go try it and see what happens.
Awesome. This looks great.
Okay.
All right, you ready, Andre?
That's right.
Okay, here we go.
Okay, time.
18 seconds.
18 seconds.
18.
And one other thing I'm going to notice, you guys actually have a place down here to keep the inventory as you do it. So it goes right below. Again, good visual cues for our other people who are packing orders. They walk up and they can see the inventory that Megan's got done. So that's a nice feature as well. And Megan, look at this. I saw that you did this. This
Yep.
is the standard. So this shows the glue always goes to this side. It also shows the brochure always goes to the back. And we want to line the edge of the brochure up with here. And we've got this sample, the standard, okay? The sample, the standard, it sits right there. Eventually, we'll probably glue it up to the wall so it's
Yep.
really clear. But that's been done too. You guys did a lot of great work.
Yep.
Okay? Let's keep going and see if we get better times. What else can we do?
Well,
Hey, Mix, before you start
Hey,
the next
Graham.
one, I got an idea. I've
Awesome.
been watching you struggle, and it looks like the most difficult part is getting all the product aligned around the can so you can slip the sleeve over.
Yeah.
I think this might be better. I took a cone and glued some popsicle sticks to this, just like this.
Graham, were you doing that back over there when we were working?
I do all sorts of stuff
Yeah,
back there when you're working.
Graham's very good at coming up with ideas, man. He's come up with a ton of good ones.
Awesome.
Well, hopefully this will be another one.
Okay.
But the idea with this is that we can slip it over the can with
So
all the
let's try
product
that.
already here.
Let's take a look. Let's see what it looks like.
Let's
Here's
do
my
it.
idea.
Okay. Oh, you know what though? Put it on the cone stand.
Okay.
Uh-oh, it doesn't work.
Let's-
Oh, we need the cone stand back. Okay, now we use oh, perfect.
Okay, ready
You
to
guys are
time?
amazing, man.
Let's do it.
Okay, let's see what
Awesome,
happens.
let's go. So my personal observation with this is the popsicle stick hits my hand when I hold this.
Okay.
But if I let go of the brochure right now, it is still going to pop out the sides a bit. So the popsicle sticks don't hold it
So
in
what can we
all
do?
the
I
way.
got an idea.
What do you want to do, Graham?
Let's make a longer cone and get rid of the
stuck.
popsicle sticks altogether.
Oh, it's stuck. Okay, so let's get a longer cone. Make a longer cone. Come on, someone make a longer cone,
Let's do it.
quick. Where's the longer cone? Quick, hurry. Okay, longer cone in action.
That was amazing.
All right.
There's that.
Killer. Okay, we have a new longer cone. Right on. You guys are amazing, man. What a team.
Awesome.
Okay, now what are we going to do? Let's try
Time
it.
it one more time.
Let's time it and see
Okay,
what we have.
let's time it. Hey, Graham, what else did you do to this cone for me?
It looks like we cut the tip off there so we can slip the sleeve on a whole lot easier.
Right,
we
so
don't
it's
have
a
to
finer
fumble over
point.
This larger point here. It's got a streamlined point, so we just slip it right on.
Okay.
No struggle there.
All right, Megan, let's rock and roll. Let's
All
see
right.
if it works.
Let's try it. I love this, you guys. You guys are awesome.
Isn't it awesome?
It
it's
is
so
so
much
good.
fun, man.
Alrighty, here we go. Ready?
Okay. Good. And we walk well.
No,
Time?
it's a smooth
20
slide.
seconds.
20 seconds. So we're getting down to
Down
about what
4.
else can we do? Any other
I got an
ideas?
idea.
Okay.
Okay, when you slip the sleeve down, you're still holding the insert out of habit, but now it doesn't fall out thanks to the longer cone. So when you get the cone on, let go of the insert and go and grab your glue with the other hand.
Okay,
So
let's
once you
try
get
it.
the
Let's see if
sleeve
it
on, you can
works.
stick it in.
We got
Awesome.
nothing to lose.
Alrighty, here we go.
Okay.
Ready?
All right.
Go. I'm
Very
liking
good.
this.
What's our time?
21 seconds.
21 seconds. So we
Okay.
still have some
Not
more
bad.
improvement to do. What else can
Another
we
thing
do?
that we do, that I've seen Megan doing, is she takes the sleeve and goes up with it to put it over the cone. Maybe take the sleeve, put it on the cone, and then set everything up. And as she grabs the cone, she's already
Megan, you
Sleeves
got that?
already on the cone.
Okay, try it.
And
Let's
she's
see what
holding
happens.
the sleeve too, so she just puts the
Good
cone on her
idea.
size on
Very
the sleeve.
good, Andre.
Let's do
Okay.
it. Because that is my biggest fumbling issue.
Right. Well, it is this little thing. So if we can address
Yeah.
this, we've got it. So go ahead.
Awesome. All right, ready for time? Go.
All you do is grab what you break it. Right, that-
17 seconds.
17 seconds. So we're
17.
down 2 seconds now. So we've got a nice system. And the difference there was the sleeve goes on here first and then goes on.
Right.
Okay? What else can we do? Anything else? Let's watch the whole process one
Let's
more
do it
time.
again.
Run through it. Okay? Everyone study everything.
Okay.
Where's the time coming in? All
Ready?
right, let's go.
Ready? Go.
Time?
21 seconds.
21.
Okay, so we see that we have a couple problems. One is the sleeve going over the glue,
Mm-hmm.
and the other one is grabbing that. I think if we can get those two components dialed down, I think we're going to be somewhere around 15 seconds. So let's take a
I think
break.
we're gonna do
Let's
it.
figure out how to solve that problem. We're going to come right
Awesome.
back, okay?
Perfect.
We're back. We made some changes. Let's take a look and see what we've done. Okay, Megan, show me what we're doing.
Alrighty. So, first things first, the cone was too far away from me. And so we moved the cone closer to me because I was taking these and reaching behind, which is too much wasted motion. So now that it's closer,
good.
I take it and boom, it's on.
Okay, that's one change.
That's-
what else?
that's
changed?
one big change.
We made a change with the can and these too, I think, didn't
Yeah, before, it seems like an innocent mistake, grabbing the can, grabbing the insert, holding it. But now, with one swoop, using two hands, done. It's
Wow, that's
one
cool.
consistent motion.
we? What else do we do?
And another thing we were going to add is when you grab the sleeve, put it over the cone, slide it down a little bit further. That way when you have the can and the insert here, you grab the cone to put it on. You're grabbing it with the sleeve, and when you put the cone onto the activator, you follow through with the sleeve and it comes right down. One
Wow.
single motion.
That those are the seconds we're looking for. Tiny little
Smooth.
things. And they
Smooth.
add up because remember, if we do 150 of these a day and we save 25 seconds of it, that's a lot of time.
That's huge.
Okay?
Let's
go
try
ahead
it.
and try that and see what happens.
Alrighty, we ready with the timer? Go.
Okay. Okay, what's the time?
15 seconds.
15, so we're way
15.
down. All right, we're rocking. Let's see if we can do it better.
That's still
okay?
way lower.
And you know, one other thing, keep going, Megan. I'm going to talk as you're going here. We want to do it relaxed. We're not under big pressure here. We want to do this all at a normal pace because sometimes it's difficult to keep up a rapid pace throughout the entire day. So we want to make this so it's simple and easy. 16 seconds. Okay, let's do another one. Let's
Starting
keep going.
to get an average.
So we're starting to get it right there. 15, 16 seconds from originally 45. Not too shabby.
It's huge.
Okay.
Okay, ready?
Ready.
Let's go.
Sleeve down further. Okay.
Sleeve
that's
down
good.
further.
One continuous motion.
Beautiful.
Over there. That goes in. Wow.
14 seconds.
Okay.
14.
You know what? 14 seconds. That's
That's
awesome.
it. That's
Megan,
Kaizen.
you did an amazing job. Andre, you did an amazing job. This is an example of what you can do with Kaizen. We took it from 45 to 14 seconds. The key is continuous improvement. The key is knowing that even with all the improvements we've made, it can still get better.
That's right.
Right? And we will continue to get it better. And this is what we do at FastCap with all of our processes. We're constantly trying to make everything better. And Megan and Andre do an awesome job of that, as well as everybody else here does an awesome job. We're even going to take a look at some of the other improvements that other people have made here because they're phenomenal as well. Thanks for watching.
The sort function within 5S is used to define what tools are absolutely needed to perform the tasks associated with that station. Any other tools are removed from the work area using a system called red tagging. Suppose you were given the job of working at a particular station within a plant. At that station, it was your responsibility to use a certain set of tools to produce a product within a limited amount of time. How efficient could you be at performing your task with all of the tools thrown into various piles all over the work cell? The red tag portion of the sort phase involves filling out and marking the unneeded items with a tag showing that it needs to be moved out of the station to a holding area. Thus, the only tools left in the work area are the ones specifically needed to perform the particular tasks associated with that station. The next step of 5S is referred to as store, set in order, or straighten. The techniques of using shadows, labels, or foam cutouts to signify what belongs or is missing from that open space is also used within the second step. The next step of 5S is referred to as shine or sweep. The reason that the shine step is important is that it enables the workers to immediately notice if there are changes with equipment or items, such as oil leaks. It also is used to determine what the sources of messes are, so that they might be eliminated. The next step of 5S is referred to as standardize. Standardization is important because it enables every worker that is tasked with working at the station to see what success looks like. It also encourages the use of successful implementations at other stations in question, helping to make all stations similar or alike in their applications of 5S. The next step of 5S is known as sustain or self-discipline in some instances. Sustainment of 5S employs the use of a scoring system with a posted scorecard or the tracking of other key process indicators associated with the station. Using the 5S system, a clean and safe work environment is delivered with groundwork for continuous improvement.